Hi YouTube, welcome back to Wtf Rc Cars. So following on with the quick vids for the G11P, I'm going to show you how to get it connected to the FS-SR12. Now this is a 12 channel receiver. You won't be able to use all 12 channels because you've only got 11, but it does give you another spare channel for either powering this, or you can have a light kit powered off it that you're not going to control, so you're just using it for the power output. But this is a two-way receiver. It'll do 3.5 to 9 volt. We've got output for S-bus and I-bus for servos. The one that says servo, that's what you'd plug the 4-channel breakout into to give you 4 extra channels if you've got a transmitter that's not a G11P. But basically you can run the I-bus sensors on this, not to be confused with the I-bus 2 sensors, so it's just the normal I-bus, S-bus. You've got the BVD to monitor voltage, you've also got the bind button, and you've also got the external bind, so you can use a bind plug on this. Same as the SR8. For this one, you've got the long-range antennas. So basically, these flight receivers, these are going to give you the greatest range, if range is an issue that you're going for with the G11P. But let's bring in and show you what you need to do. So first off, we'll go to select model. So select the model you want to be on. Then you can give it a name. So if we quickly delete that, come across. Remember to hit the little tick so it can come out. Then we're going to go into his RX menu, failsafe. I'm going to set to no output, bind. So on this one we can go routine, which will give us the greatest distance, or you can go fast, which will give you the fastest response, but not necessarily the greatest distance. Just play about with them, really don't matter. The RF standard, so if you set it to 1-way, you're not going to get any telemetry back. Leave it on 2-way, that gives you telemetry and everything. RX type, leave it on standard because it's not an ESC one, so we don't have to change that. Output, we've got PWM and I-bus, PWM and S-bus, PPM and S-bus. So for me, I'd leave it on I-bus because you're more likely to use I-bus stuff with this than anything else, and it wants to be on PWM if you've got PWM servos. Servo frequency, so analog is 60 Hz, digital is around 333, and that's what most electronics run at, unless you've got Traxxas, which can barely make 280. I don't understand why Traxxas are so bad still. But for this one, you can power it off any of its ports other than the BVD. I won't power it off that one. So if we press and hold the bind button, connect power to any of his inputs, and on this side and on that side, the lower is all negative, then you've got your positive, then your signal pins along the top. So we get this flashing fast. If it doesn't flash fast, it's not in bind mode. So let's get it bound. So even though this is a flight receiver, it will bind to the ground transmitters absolutely fine. So if we look what we've got set up as stock, we start from channel 1 here. So you got 1 to 10, 11, 12, and then the BVD socket for your sensors and socket for the output to the breakout for extra channels. So if we go in channel 1, you can see we've got channel 1 works fine. Channel 2 is going to be as throttle. And then, as I've shown in quite a few other videos, if you want to assign any other channels, so if we go all the way down to channel 11 and we set as control, so set this to a variable VR1. Yeah, we'll run it as VR1. So let's get our little servo plugged into channel 11, which is going to be all the way around on this side. So again, your signal wire to the top, and then as we move that, you should see the servos moving. Now this dial is very useful if you want something with extremely granular control, but we will still get power out on channel 12. You still got your signals, sensors that you can use. So as with the 8-channel variant, if we get our BVD cable, just make sure you connect it to the right output on here, or input. It's the third one down, and then you get your positive pin and connect it. We can have the BVD voltage read out on the screen, so we've got 7.63 volt from our power supply. Now the only thing you need to remember, the BVD, if the battery or ESC that's powering the actual receiver, so if you've got a battery pack that's powering the receiver directly, or your main battery pack is powering your ESC and then your receiver, to read the BVD voltage you only need the positive cable. If it's an external battery, so if you want to measure a battery that's not the one that's powering your receiver and everything, so if we've got another little LiPo, and let's plug this in, so if we give it positive, you'll see we get nothing on the BVD. So you have to complete the circuit with negative. So we got 7.35 volt. But if you see, when you power it, when you're using the one that is powering the actual receiver, be it directly or through an ESC, you've already got negative, so all you need to give it is the positive feed, and it'll measure your voltage. If you plug the negative in, it won't do anything. You've already got negative connected. If you plug negative into positive, you will destroy the cable and probably the receiver. So that's why they advise, if it's the one that's powering your receiver, either directly or through an ESC, tape the black cable up or cut it off so you don't accidentally put it into the positive, because it'll cause a dead short. Other things we can do with this. So if we hop into menu, you can go and display all your sensors. We can go to set sensor, and you can add it on the sensor screen. So we can go down to BVD. You can also set an alarm for it. So we can set a low voltage and a high voltage. You've got to work out what your actual pack is. So if we're going to run off a 2S, then you can work out your lowest voltage. If you look at 3.3 volt per cell, so you'd have 6.6 volt as your lowest that you want to go, and then you're going to get an alarm at that. Personally, I wouldn't run it below 3.3, so probably set it to 6.7 and you'll get an alarm just before it gets to 3.3 volt per cell. But it's entirely up to you. Some guys run the LiPos all the way down to 3 volt, and then your high alarm, that wants to be set at something that your battery will never be above. So standard 2S 8.4 volt, shouldn't go above that. And if the battery voltage goes outside of this range, so you get a warning. It's not a massive warning, but it's a warning, just to let you know that your voltage is outside of that range. So I'll turn that off, but you can see on the sensor screen we've got it. And you can also calibrate the BVD voltage. So If you've got a really accurate voltage meter and you decide that this reading isn't accurate enough, you can come in here and you can actually change it. So it'll correct the voltage and make it read exactly what your extremely accurate voltage reader does. I've been asked a few times how I get into these menus, so press up, takes you to the one where you can see all your channels, see what they're doing. Just tap down, gets you to your sensor screen. But yeah, that's the Flysky FS-SR12. Technically a flight receiver, but you've got 12 channels, 11 of which you can use with the G11P. You can use the BVD, sense and servo port with iBus and S-Bus. You've also got the 12 channel. If you want something that just needs power, you can power it off this receiver and use all 11 channels. Or you could use channel 12 just for your power in. So if you needed to power this but have all 11 channels fully open, you've got that option. It'll work absolutely fine for you. You can power it off of a battery pack like we do with Nitro cars, or it's more than happy running straight from the ESC on an electric vehicle. As I said, the input to this is 3.5 to 9 volt DC. But that's just a first look and a run you through how to bind on the flight receivers with the Flysky G11P. Hopefully you find this useful, entertaining, just like listening to my incessant ramblings. But don't forget to like and subscribe, hit the notification bell, share to friends and family, and catch you guys again in the next one.